Pre-calculus 8.2 day 1, we're going to be looking at matrices, something that you maybe have not worked with before. And so let's talk with what is a matrix. So that's your singular term. And a matrix is a rectangular array of numbers enclosed in brackets. So a matrix is just a set of numbers. It's kind of like a spreadsheet. So for example, you might have this as a matrix. And we have dimensions of a matrix. And the dimensions go, it is m by n, and m is the number of rows by the number of columns. Those are known as the dimensions of a matrix. And so in this 1, 2, 3, 4, 5, 6, we have 2 rows and we have 3 columns. It is a 2 by 3. That's how we talk about it, a 2 by 3. Some other notations. So if we have row 1 and column 1, we're going to call that the element A11. If we have row 2, column 3, we're going to call that A sub 2, 3, second row, third column. And the first one, A11, first row, first column, that element is 1. So that each item in there is known as an element of the matrix. So each number in there is known as an element of the matrix. So if we have A23, that is the second row but third column, that element has a value of 6. So there's elements, and they're also called entries. An element or an entry of the matrix. So that is a 2 by 3. If I write it, again, you need to know the row by columns, the number of rows or the number of columns. The size on this is a 3 by 2. Those are the dimensions on this matrix. So down below in example 1, it says solve for A11, A12, A21, A22. Well, they are just corresponding. And so A11 is the first row, first element, which is -3. A12 is first row, second column, which is the value of -2. And then A21, second row, first element. And then A22, second row, second element, second column. And there you have it. So then you're going to be asked to evaluate matrices. And so you're going to be add and subtract to start. And when you do that, you're going to add corresponding entries, meaning numbers that are in the same position. So this is a 2 by 3, this is a 2 by 3, 2 rows, 3 columns. And so you just start by saying, okay, I'm going to add up the 1 and the 0, which is 1. Then you switch and you go to the first row, second entry. And you add 5 and 0 and you get 5. Oops. Then you move to the next set of corresponding entries, and you add -3 and 0, which is your -3. And we're done with the first row. And so then you do the same kind of process. In the bottom, you are going to add the 0 and the -3. Then you're going to move and add the 2 and the 4, which you have 6. And then lastly, add the 7 and the 1, and you have 8. So you're adding corresponding entries. And so when you're adding, you're going to end up with the same size matrix as you start of each of the ones you were adding. So you end up with a 2 by 3 matrix. So in part B, when we start adding, we have the 1 and the -3 is a -2, 2 and 1 is 3, but then, oops, they are not of the same size. It is impossible to add these. So we'll say it's, that some of these is undefined because they do not have the same dimensions. So in order to add or subtract matrices, they have to be the same size. This first one is 3 rows by 3 columns. The second one is 3 rows, but it's only by 2. You cannot add or subtract them because they're not the same size. All right, well, we also have some multiplication things, and we're going to start with where we have a number times the matrix, and that number is called a scalar. Scalar multiplication, we call it. And when we have scalar multiplication, so this means we're taking a -3 times this matrix A, you take each entry in matrix A times 3. So, or times the -3. So -3 times 4 is a -12. -3 times -1 is 3. -3 times 0 is 0. -3 times 4 is a -12. Dropping to the third row, -3 times -3 is 9. And -3 times 8 is -24. And that is scalar multiplication. You multiply every single entry of the matrix by the -3. So in part B, we are going to have scalar multiplication for both the A and the B, and then finish up by adding. So we already, in part A, did a -3 times A, so we'll just bring that value down. And to that now we are going to add matrix B, but it is times the scalar 2. So we need to take each element in B times 2. And then you are to, notice that we're using the brackets there. So now we're just going to add up corresponding elements. So we have a -2, 12 and 0. We have 3 and 8, add up to 11, 0 and a -2, a -12 and 6, 9 and 2, and -24 and 14. So you add corresponding entries, and there is your end result, and that is your final answer for that. So here we have directions perform the indicated matrix operations. Well, we have parentheses and we have 2 by 2 matrices that we are being asked to subtract. And so we have on the outside of that a scalar. I'm going to go ahead and do what's inside the parentheses and subtract these two. That means we're going to subtract corresponding elements. We start with 8 minus 10. Then we have 11 minus 3. Then we have a minus 15 minus 5 is a -20. And 6 minus the -6 is 6 plus 6. And we have 12. So there inside we have, oh, what did I do? 11 minus 3, that's not going to work. I was I was looking at my notes and I did it after I multiplied by 1/2. Okay, so we have the -2, the 8, the -20, and the 12. That's better. And then multiply each element by 1/2. That's multiplying by a scalar, and that's where we'll get the 4. And that is your end result. All right, so now finding the product of two matrices. We can't multiply all matrices. There's certain dimension things that we need to have for it to work. It's a little different than adding, subtracting. Adding, subtracting, you have to have exactly the same. That's not quite the same when we go to multiply matrices. And so when we multiply matrices, then we're going to consider the dimensions. The first matrix is an n by m matrix. Then the only way you can multiply is if the second matrix has the same dimensions. Not the same dimensions, but the number of columns in the first has to match the number of rows in the second. These two dimensions must match. So we have an n by m and an m by p matrix. These two right here must match. That is, the number of columns of the first must match the number of rows of the second. And then the resulting matrix, the size of the resulting matrix is a n by p matrix. That is the resultant matrix size. So, and finding the product of A times B, this is a 2 by 2. This is a 2 by 2. And these match, so therefore we can proceed. And the end result will be a 2 by 2 matrix. And then how do we multiply these? Well, we are going to start with this row. Oops. We're going to start with this row, sorry. I said row and then I did a column, by this column. And so, we're going to multiply corresponding elements. So as I go through this, I'm going to have this matrix where I've got row 1 here times column 1 of the second matrix. So I have this 1 times 0 plus a -1 times 3. And I'm going to put that all together, and that's one entry of our resultant matrix. Then I am going to keep row 1, but move to column 2 on the second matrix. So stick with row 1 of the first, but use column 2 of the second. And so multiply corresponding entries, 1 times a -2 plus a -1 times 1. And I've run out of columns on my second matrix, so I am done in terms of the number of columns I'm going to have in my resultant. So now what we do is we switch and we work with row 2 in the first matrix. And we go back to working with column 1 in the second. And we multiply corresponding elements. So we take 4 times 0 plus 3 times 3. And that will be one entry in the resultant matrix. Then we change the column on the second matrix. And now we multiply that bottom row of the first times the second column of the second matrix. Multiply corresponding entries. 4 times a negative 2 plus 3 times 1. And then we're just going to simplify those. I just made those brackets a little too big. And so that first element, 0 plus a negative 3, is negative 3. First row, second element, negative 2 plus a negative 1 is a negative 3 again. Going to the second row, we get 0 plus 9 is 9. And then a negative 8 plus 3 is a negative 5. And that is a 2 by 2. The dimensions are 2 by 2 is what we expected. And that is your resulting end product. Now, if we multiply these in the other order, we actually don't always get the same result. Multiplication is not commutative with matrices. So if I put B first, and then I'm multiplying that times A, and so then you need to show this, you have to show a middle step here. You are taking, oops, not what I wanted to do. You are taking this column, I did it again. I don't want that column, my fault. We are taking this row, and we're going to go times this column and multiply corresponding elements. So 0 times 1 is 0, plus negative 2 times 4 is negative 8. And I want to see that work. Then we move to the second column, staying with the first row. And so 0 times a negative 1 is 0, and a minus 2 times 3 is a minus 6. And I'm just double checking. Yeah. All right, and then we're going to, we ran out of columns. So now we're going to move to the next row. So we are going to use this row but we're going to multiply with this column. And so we take 3 times 1 is 3, plus 1 times 4 is 4. Then we switch the column on the second matrix, stay with the second row on the first, and multiply corresponding elements. 3 times a negative 1 is negative 3. 1 times 3 is 3. And so the end result is we have a negative 8, a negative 6, and then a 7 and a 0. And that is the end result. Notice that A times B was this result, but B times A was this other result. They are not the same. So these are not commutative. It's not like in multiplying 3 times 4 is 12 and 4 times 3 is 12. It doesn't work that way. We say A times B does not equal B times A. If it does, it's an exception. It doesn't happen very often. All right, so in part C, let's do another multiplication. This is a 2-row, 2-column, and then the second is a 2-row, but it is a 3-column. Because these match, I can multiply them, and my end size is going to be a 2 by 3. So as you go to multiply these, again, we are going to start with this row, get that right this time, and this column. And so you should show you get 0 plus 2. Then you switch to the next column and multiply corresponding. You get a -6 plus 1. Then you're going to switch to the third column of the second one, multiply corresponding entries. You get a +4 plus another 4. And then we're done with that row. And then we are going to switch the first one to working with the second row and then move through the columns of the second matrix. And so as I multiply, I get a 4 and a -2. And then move to the next column of the second one, and you get a 12 minus 1. And then move to the third column of the second one and multiply, and you get a -8 minus 4. And then finish it up by simplifying all of those. And there you have your end result. And it is what we expected. It was a 2-row by 3 column. All right, so example 6, find this product. And we did this one. This is, that's going to go a little faster because it has quite a few zeros in it. This is a 3 by 3. This is a 3 by 3. So we can multiply because those match, and the end result is going to be a 3 by 3. So we are going to start with this row and this column. And in this case, because you have so many zeros, you don't have to show quite as much detail because you get 4 times 1/4, which is 1, plus 0 times 0 plus 0 times 0. So that's just its value. And then I'm going to move to the second column in the second matrix, keeping the first row in the first. And I get a 4 times 0, 0. 0 times -1/9 is 0, and 0 times 0 is 0. It is a 0. And then as I move to the third column of the second one, as I multiply corresponding, 4 times 0 is 0, 0 times 0 is 0, 0 times 1/2 is 0, I get another 0. And then we are going to switch to the middle row. And as I multiply by the first column, I get a 0, a 0, and a 0, so that's all going to add up to 0. And as I switch to the second column, now it'll be different. I get 0 times 0, but -9 times a -1/9 is 1. And 0 times 0 is 0, so that's that second element of the second row. And then switch to the third column, and you have 0 times 0, -9 times 0, and 0 times 1/2, that product is 0. And then switch to the last row and move through the columns. And you get 0 times 1/4, 0 times 0, 0 times 5 is 0. Switch to the next column, multiply corresponding elements. You get 0 times 0, 0 times a -1/9, and 0 times 5 is 0. Move to the third column, and then 0 times 0, 0, 0 times 0 is 0, and then 5 times 1/2 is 5/2. And notice that we ended up with a 3 by 3, which is what we expected for dimensions. And that's how you multiply matrices.